Hi everyone, welcome to this next video. So in this one, what I've put together is 20 questions for the foundation paper, style of paper 1. So these would be all non-calculator. What I suggest you do is maybe go through, pause the video, go through the questions on the video, and then unpause it, mark the questions, and then if you got it wrong, if you struggled with a particular question, then what you should do is click on the timestamp. Click on the link next to the timestamps I've put and watch a video on that topic and go through it again, or do some more revision on that topic, find some additional resources just to help you go through and solidify the things that you're getting wrong. So it's worth doing this. Pause the video as I show the questions, and then what you can do is mark it yourself, and then if you got it wrong, you can then spend a bit more time on that topic. Okay, so we're going to jump straight in. We're going to start looking at the first style of question now. So question 1 says convert 380 minutes into hours. You can see as well on the right hand side, I've put how many marks each question is for you as well. So looking at this one, 380 minutes into hours. So we know 60 minutes is 1 hour. I'm basically just effectively doing 380 divided by 60 to see how many times that goes into it, right? So, or you could go 60 plus 60, that's 120, plus 60 is 180. So I know that that would be 3 hours, etc., etc. Now, obviously, depending on how well you know your times tables, 60 goes into 386 times. So you know that that is going to be 6 hours. And then 6 times 60 is 360. So there's 20 minutes left. So it's 6 hours and 20 minutes. Okay. Nice easy start for us, only worth 1 mark. There we go. Order these decimals from smallest to biggest is the next question. Now the way I like to do this is take each number and put it on top of each other, lining up your decimals. So 0.02, 0.203, 0.0023, and then 0.0203. Then from there, what I suggest you do is any gaps that you've got where it doesn't make the decimal places the same, just fill them up with zeros. And if you've got a different colour, good to use a different colour. Then what you want to do is start at the first row, go right, they're all zeros, so they're all the same. Then go to the second list. So we've got 2, 0, 2, 0, 0. So now I'm going smallest to biggest, so I'm looking here, here, and here. So from this, this, and this, they're all zeros. Go to the next column. So that's a 2, that's a 0, that's a 2. So it won't be one of those. And therefore you can see that this is your smallest number. So your first number will be 0.0023. Okay, so it's that one there. Then I cross that off. Then I go back to the start again. All zeros. Next row, got a 0 and a 0. Next row, 2 and a 2. Next row, 0, 0. Go to the next row, 0 and a 3. So then this one becomes your next smallest. So 0.02. Cross it off. Go back to the start. That's a 0, 0, 0. 2, 2, and 0. So therefore, you know that's the next smallest. So it becomes 0.0203. Cross it off. Go back here. 0, 0, 2, 2, 0, 0, then 0, 3. So then this is the next smallest one, 0.2, cross that off, and then you're left with 0.203 as your final one. So always go back to the start each time, and then you're looking for the next smallest number. If 2 numbers match up, so like for example where it's 0, 0, 0, go to the next number and find the next smallest one. Okay, so that's your next one. Question 3, we need to be looking at a bit of BIDMAS here. So this part is what you do first. So 3 times 5 is 15, and then add your 6. So just remembering that BIDMAS, we're doing the brackets first, indices, division, multiplication, addition, and subtraction. And with indices, it could also be roots as well. Okay, so it could be the square root of something that would come second as well. In this case, we're doing the multiplication first. 3 times 5 is 15, plus your 6 is 21. Okay, so nice easy start on the first 3 questions. These are the questions you need to make sure you are smashing and getting done fairly easily. Okay, moving on now. In a shop, 12 bananas cost £3.60. Assuming you can buy bananas in singles, how much would 17 bananas cost? Okay, so what I know is that 12 is equal to £3.60. So what I need to do is get that to 1. Okay, so to go from 12 to 1, divide by 12, which means I'm dividing this by 12 as well. And it's nice to see here that 12 does go into this quite nicely. Okay, so 12 into 360p or £3.60 is 30p. Okay, so if you saw it as 360 divided by 12 would be 30. So one banana costs 30p. I need 17. Or just think to yourself, I've got to times that by 17. So therefore I'm timesing that by 17 as well. Now, if you don't have a calculator, because we're talking about paper 1, best way to do it is to set it up as column method. So 7 times 0 is 0. 7 times 3 is 21. Put your placeholder, because I'm now working here on this tens columns. Then you do 1 times 0, which is 0, and 1 times 3, which is 3. Add it all together. So it becomes £5.10. Okay, so you'd get 1 mark for getting the 30p for one value, and then the second mark for getting the right answer of £5.10. Okay, question 5. So we're looking at fractions. We are adding. So just remember, when you're adding or subtracting, you must make the denominators the same. If the question was asking you to multiply, you just do top times top and bottom by bottom. If it's asking you to divide, use keep, flip, change. So let's have a little look at this. This is how I answer these first of all. So you want to turn them into improper fractions. So you do 5 times 3 first of all, and then add the numerator. I'm going to do 3 times 5 and then add the numerator. So 5 times 3 is 15 plus your 2, that becomes 17 over 3. And then 3 times 5 is 15 plus your 1 is 16 over 5. You don't get any marks for doing that. But then from here, what you want to do is make your denominators the same. So I'm going to times this by 5 and I'm going to times this by 3. Okay, if you're ever stuck, just multiply this one by the opposite denominator, multiply this one by the opposite denominator here. Now, 17 times by 5, again, without a calculator, you can put it in the column method. 7 times 5 is 35, and then 5 times 1 is 5, plus your 3 is 8, so 85. So we're saying this fraction here turns to 85 over, and 5 times 3 is 15. Just remember, whatever you do to the top, you have to do to the bottom. Same here, 3 times 16, well 16 plus 16 is 32, plus 16 is 48, so hopefully you don't need to do column method to work that out. And 3 times 5 is 15 as well. Now my denominator is the same, so that would be where I get my first mark. Then all you're doing is 85 plus 48. Again, if you want to just make sure, write it out in full so you don't make a silly mistake. So 8 plus 5 is your 13. 3 carry your 1. 4 plus 8 is 12, plus your 1 is 13. So it gives you 133 over 15, and that would be your second mark. And then finally, just get in the habit of putting it in its most simplistic form. So this is a top-heavy fraction. You're saying to yourself, how many times does 15 go into 133? Well, 15 times 10 is 150. So then 15 times 9. So you take away 15 from that, which would give you 135, right? So you know it can't be 9, which means it's 8 times. And we know then if we then do 15 times 8, we take away 15 from that, which would give me 120. So how do I go from 120 to 133? It would be 13 left over. So nice, you can see my method here. I was trying to get as close as I could. I knew 15 times 10 would be 150. Took away 15, which gave me 135. 135 is still too high, so I need to get it to below 133, which gives me 8 times. There's my big 8, and 8 times 15 was 120, so that means there was 13 left over. So 13 over 50 would be your third mark for simplifying it. Just be careful, sometimes it might ask you to simplify this part as well. It say give your answer in the most simplistic form. If it's something like 12 over 15 there, then you'd realise they both divide by 3. Okay. Next one here then, laws of indices. So first of all, The line here, the fraction, means that we're dividing. So deal with the numbers first. You can do 18 divided by 3 and your answer is 6. Okay, then what you're doing is x to the power of 5, and this is effectively an x to the power of 1. When you are dividing with indices, you subtract. Okay, so you subtract the indice when you are dividing. X to the power of 5 divided by x to the power of 1 actually gives you x to the power of 4. And then the same thing here, y to the power of 2, y to the power of 1 just becomes effectively y to the power of 1 because you're doing 2 minus 1, whereas we've done 5 minus 1 there to get the 4. If it's to the power of 1, you don't need the 1, so your final answer is just 6x to the power of 4 and then y. You'd get 2 marks for this question probably, depending on how complicated it is, but just make sure you do the numbers first and then work with the indices. Right, moving on now to the next part. So we're moving into slightly more wordy questions where they're going to be involved a few more processes, additional steps. Okay, so we've got a ratio question here, and with ratio we need to just determine what style of ratio it is. I've done a whole video on ratio, so it could be worth looking at that one if you're not 100% sure and you want a little bit more information on it. Look in the description, I'll put the link to that video as well in the description. So it says the ratio of adults to children. So the first thing I'm going to do is write adults to children, and I'm going to write 3 to 8 at a party is 3 to 8. So I've got that, I've written it down, I've organised it. Now you can see here this says there are 15 more children. So this is a ratio question where there is more than involved. What that means is I'm saying that the difference in those ratios, because if you want to think about it like boxes, we've got 3 boxes for adults, and then we've got 8 boxes, 8 boxes for children. Those 3 match up those 3. What we're saying is this many boxes here is effectively 15 children. Okay? Because it's an additional. It says there are 15 more children at the party than adults. So what I'm effectively saying is this many boxes is equal to 15 children. Well, the difference between 3 and 8 is 5, and you can see I've got 5 boxes there. So you could say 5 ratios or 5 boxes is equal to 15 children then. In any ratio question, the first thing you want to find is one ratio. Okay, so always try and find that first. To go from 5 to 1, divide by 5. So I need to divide this side by 5 as well. So we can say that one ratio is equal to 3. Okay, that would be your first mark. For finding one ratio, you'd always pick up a mark. So what I'm then saying is in each box that I've drawn here, there are 3 people in it. So each box represents 3 children or 3 adults. Therefore, the question's saying to me, how many people are at the party in total? Well, I've got 9 adults there. 3 times 3 is 9. And I've got 1, 2, 3, 4, 5, 6, 7, 8 boxes. 8 times 3 is 24. So I've times that by 3. I've times that by 3. So we've got 9 and 24. So there's 9 adults, 24 children. So altogether, there are 33 people. Okay. The other way you could do it is add the ratios together, which is 11, and then just times it by 3 to get 33. Okay. And that makes sense as well because we know that there are 15 more children, and the difference between those two is 15. Okay. Perfect. Next one then, moving on. So we've got a bit about scale drawings and the model here. So a model car has a scale of 1 to 200. Key thing to identify here is that 1 to 200 means 1 centimetre is the equivalent of 200 centimetres in real life. Okay, so 1 centimetre of my model actually represents 200 centimetres, which is 2 metres in real life. So the model car is 3 centimetres long. So if I just draw my model car here, my very artistically drawn car. There we go. What I'm saying is that this car is 3 centimetres long. I know that 1 centimetre is 200. So if I've got 1 centimetre is equal to 200 centimetres, I need to get it to 3 centimetres. So I'm timesing that by 3, and I'm timesing that by 3. Therefore, that gives me 600 centimetres. That's your first mark. So we've actually managed to get it to the correct length. It could be 3.5 that it might ask you to do. So if it was that case, you times it by 3, and then add half one again. So if it was 3.5, then the answer would be 700, because 200 times 3.5 would be 700. How many meters long is the car in real life? Well, we've turned it into centimeters, so we now need to get our head around the conversion. 100 centimeters is a meter, so 600 centimeters is equal to 6 meters. So your answer would be 6 meters in this case. Okay, drawing a picture, if it helps you, do it. Obviously it might not, but actually drawing and visualizing stuff sometimes does really help in exams. Okay, so we're moving on to a little bit of algebra now, and trying to understand how you'd work these kind of questions out where there's unknowns involved. So it says Amanda is 4 years older than Chris, and Chris is twice Edward's age. So first thing to understand is who we've got. So the way I like to answer these questions is I write down the initials. So we've got Amanda, we've got Chris, and we've got Edward. We've got Ace. Amanda links to Chris. So you can draw an arrow there saying Amanda links to Chris's age, and then Chris links to Edward. So what we can say is that ultimately from Amanda we go to Chris, and then from Chris we go to Edward. So if I start at Edward, Edward is my starting point. So my starting point I can call X, because then everything else is going to feed from him. It tells me Chris is twice Edward's age. Well, if Edward is X, think about what you could call Chris then. So we can call it 2X. It's not X plus 2, because X plus 2 would be 2 years older. 2X is 2 times X, so it's 2 times Edward's age. And then it says Amanda is 4 years older than Chris. Well, we now know Chris's age. Chris's age is 2X. So Amanda is Chris's age, and then 4 years added on. So I can write that as 2X plus 4. Just this process here for representing it in algebra gets you a mark. It says their combined age is 64. So when I add all this together, I get 64. So if we think about that logically, I'm saying Amanda plus Chris plus Edward equals 64. Well, let's just write that out. 2X plus 4, Amanda, plus Chris plus Edward is equal to 64. And now let's just tidy this up. 2, 4, that's 5x. Okay, really important to be aware of. That's 2x's, so that's 4x's, that's 1x, that's 5x's. It's not 3x's, it's 2, 4, and 5. Then we've got this 4 as well, plus 4 equals 64. So now I need to go to solving this. And if you're unsure on solving, it will be worth looking at the video I've done on solving equations to get your head around it. Take the 4 over, it becomes a minus 4. So we're saying 5x is equal to 60. And then to get rid of the 5, we divide by 5. So x is equal to 12. Okay, that would pick you up another mark for finding the value of x. So let's just move that to the side. If we know x is 12, I can now go back to what I've done at the start. And I know Edward is x. So therefore Edward is 12. Chris is 2x. So 2x would be 2 times 12, which is 24. And it tells me that it's twice his age anyway, so that works. And Amanda is 2x plus 4. Well, it's 24 plus 4, which is 28. Okay, so that's how you would solve those questions where you've got a concept involved in and around an unknown ages, but you've been given a total. Okay, you have to form the equation yourself and then solve it. Okay, without a calculator, work out 32.4 times 3.7. So best thing to do, remove the decimals first, and we'll put them back in at the end. So we're saying 324 times 37. Okay, using my column method. So you do 7 times 4 first of all, which is 28. So I put my 8. I'm going to carry up here so it's out the way. Then I'm doing 7 times 2, which is 14. Plus your 2 is 16. So put my 6, carry my 1. 7 times 3 is 21. Plus your 1 is 22. So I've dealt with the 7. I now need to deal with the 3. And because that is effectively 30, I put my placeholder of a 0. Then I'm doing 3 times 4, which is 12. So I put my 2, carry my 1. 3 times 2, which is 6, plus my 1 is 7. Then I'll do my 3 times 3, which is 9. So you should end up having 2268, and 9720 would get you a mark for having those digits. And then from here, all you need to do is just add those together. So 8 plus 0 is 8, 6 plus 2 is 8, 7 plus 2 is 9, 9 plus 2 is 11. So for having 11,988 somewhere would get you a second mark. And then you need to figure out where to put your decimal. Okay, really important. In the question, there's one decimal place there and one decimal place there. So that's 2 decimal places altogether in the question. So what I need to make sure is in this answer here, so 11988, I have 2 decimal places. So my 2 decimal places are going to be here because there's an 8 and an 8 there. And that makes my 2 decimal places. Also think to yourself, does that number make sense? Well, if that was 33 times 3, for example, then it would be 99. And obviously that's slightly higher. That's closer to 4. So it kind of makes sense it'd be near the 120 mark. Okay. So next one, we're dividing with decimals. So bus stop method here, you would do 54.8 in the bus stop, and then 0.8 goes on the outside. What I need to do is I need to make it so that this is a whole number. So to get that whole number, I'm just going to times it by 10, okay? By timesing it by 10, that turns to 8. If I times that by 10, I have to times this by 10, so then it becomes 548. So the number on the outside, you don't want a decimal, so you need to make it decimal. So in this case, I times it by 10, which makes it 8. It could be that you times it by 100, which would make it 80. And if I times it by 100, I'd have to times this by 100 as well. But because I'm timesing this by 10, I just times this side by 10 as well. So now what I've got is instead of doing 54.8 divided by 0.8, I'm actually doing 548 divided by 8. How many times does 8 go into 5? Well, it doesn't. So put that, carry my 5. How many times does 8 go into 54? Well, 6 times 8 is 48. I'm on 48 and I need to get to 54, which means there is 6 left over. Okay. How do I get from 8 into 68? Well, 8 times 8 is 64. So that's 8 times. But now I've got a remainder. So if you end up having a remainder when the number's finished, you put a decimal place, add a 0, and then whatever you've got to carry. So in this case, 8 times 8 is 64. To get to 68, there's 4 left over. How many times does 8 go into 40? And the answer is 5. And because I've now got no remainders, I can stop. So my answer to 54.8 divided by 0.8 is actually 68.5. Okay. I don't need to do anything to my answer to change it, because when I times this by 10, I've times this by 10, the sum is still relative to itself. I don't have to then convert anything back at the end. Okay. So that's your answer to question 10. So we're halfway through the paper now, gone through some of the more simplistic stuff, and now we're moving on to slightly harder stuff now. So next one is a Best Buy question for us to look at. Okay, so ultimately, when you get a Best Buy question where it says to you which one is better value for money or anything like that, or where should I buy from, what you need to do is you need to be able to make it so you can compare the values. At the moment, Shop A, Shop B, I've got 2 SIM contracts here, so 2 offers for a mobile SIM only. Shop A is £20 per month, Shop B is £15 per month. So the value of money is different. Unlimited calls and text, that is the same as that. And this is the thing that's different as well. 30 gigabytes of data, 20 gigabytes of data. So what I need to do is I need to either make the gigabytes the same or the price the same so I can compare it. Or you need to make it so that you can find it for £1 or for 1 gigabyte. So the first way I would answer this, and the first thing I would do is split my page in half. And I'm going to write Shop A on the left-hand side, and I'm going to write Shop B on the right-hand side. The reason I do that is so I make it really clear for an examiner where my working out is. An examiner is going to be marking a lot of this question. You want to make it really easy for them. So £20 is for 30 gigabytes. So I'm just going to write that down. And this one here is £15 is for 20 gigabytes. So I need to make something the same. Well, what I'm going to do first of all is I'm actually going to turn this to 60 gigabytes. So I'm going to times that by 2. And then I'm going to times that by 2 as well. So I'm saying for £40 a month, if I was to use Shop A, £40 a month, I'd end up with 60 gigabytes. And what I can actually do is I can times this one by 3 to make that to 60 gigabytes, okay? So if I times that by 3, I then have to times that by 3, which means I get £45. So what you can see is that when I make the gigabytes the same, Shop A is actually cheaper to Shop B. So Shop A would be my cheaper option. You must make sure you write down which one is better. Shop A is better value, okay, or is cheaper, or whatever it might be that it's asking you. You have to make that statement. Now let's look at another way of doing it. So instead of doing that, what I could do is I can actually turn it to £1. Okay, so how I can work out what I get for £1. So in that case, I'd divide by 20, and in this case, I'd have to divide that by 20. Now, 30 divided by 20 is not the easiest thing to do. However, divide it by 10 ends up with 3 over 2. That's an improper fraction, which is actually 1.5. So 3 divided by 2 is 1.5. So I'm saying with Shop A, £1, I get 1.5 gigabytes. Well, let's do the same here with Shop B. So for £1, I've got to divide by 15. So I therefore divide this side by 15 as well. 20 divided by 15. Think about what I can divide these both by. They both divide by 5, okay, because we treat them like improper fractions. So 20 divided by 5 is 4, and then 15 divided by 5 is 3. So it becomes 4/3, which is 1 and 1/3. So 3 goes into 4 once, with 1 left over, which is 1.3 reoccurring, okay? So that's 1.3 gigabytes. So for £1, I get 1.3 gigabytes. And here in Shop A, for £1, I get 1.5 gigabytes. So that's better value for money again. Okay, that way is a little bit harder to work it out. And then the final way you could do it is by making the money the same again, but instead of making it to £1, because that was quite a complicated way of doing it, and if you had a calculator, that would probably be easier. What I can do is I can say to myself, right, okay, I've got £20, I've got £15. What number do they both go into? Well, I can make this to £60 again. So instead of it being 60 gigabytes, I'm now making it to £60. So I times that by 3, which means I times this by 3, so I get 90 gigabytes. So for £60, I get 90 gigabytes. And then how do I turn £15 into £60? Well, I times it by 4. If I times that by 4, I get 60. And I've got to times that by 4, which means I get 80 gigabytes. And therefore, again, you can see for £60, 90 gigabytes is much better value than £60 for 80 gigabytes. Okay, so any one of those 3 ways to do it, it tells you Shop A is the better value for money. Okay, so for making things the same or comparing them, you pick up a mark or 2 marks in this case, and then for saying which one is better, it's called a communication mark, you get your last mark there. Okay, some angle rules, things that you need to know. So with this, you need to start thinking about, you've got your Z shape, which is alternate. Again, if you're not sure, watch the video on this. Corresponding is your F shape. And your final one is co-interior, which is your C shape. And they add to 180. Okay, so they're the things you need to be aware of and you need to know. So let's have a little look and see what I can work. It also says give a reason for your answer. So let's do W first of all. Now, first thing, when you get these questions in your exam, I would just work out every angle you can and not even worry about what the question's asking you to do. Just work out every single angle and you know you're probably going to pick up some marks. So first thing I'd do is I'd go, right, well, 50 plus 70. Okay, that's going to give you 120. And therefore you know that this whole thing here is a straight line. So it must add up to 180. So you can do 180 minus 120 to get 60. So you could say W is 60 degrees. So W equals 60. And your reason is angles. So you must give the reason on a straight line equal 180. Okay. So that's your first reason. That's your first rule there that we've done for W. I'm just going to rub this out down here so I've got more space. Okay, next thing, what can I work out next? There's always clues in these questions, okay? So I would say the next thing I'm going to look at is this triangle. Well, what type of triangle is it? It tells me here this line and this line are the same. So that is an isosceles triangle, which means that angle there is also 70, because in an isosceles triangle, the base angles are the same. Okay. So that's a reason I'm writing down. It didn't ask me to find that, but I'm giving a reason for that. And then from there, now I can find this purple angle. Well, if I've got 70 and 70, that makes 140. And here's my triangle. Angles in the triangle add to 180. So I do 180 minus 140 to get 40 degrees. So I can say y is equal to 40 degrees. And my reason is angles in the triangle add to 180. Common rules that you're going to see, so you probably will see triangles a lot. So always think about that rule about adding to 180. Perfect. So we know we're in a good position. We've picked up a couple of marks at least now. Now, next one, X is probably the next one for me to look at. So this angle here. Now, straight away, thinking about the fact that we've got angles in parallel lines, if I do this, I've got a backward C shape. So they're co-interior. If they're co-interior, they have to add to 180. So I'm doing 180 minus 50 to get 130. So therefore, that angle there is 130 degrees. So that's X equals 130 degrees. And my reason is co-interior angles add to 180. Okay, because that bit there is my backward C. If it was this way round, then I know that this here, so these two angles together, that's going to be 130 degrees. And then what here, so these two and these two together will end up making 180 as well. So that's your normal C. This is your backward C. So that's what you're looking for your co-interior. Okay, so finally we can now find Z, and there's a couple of ways to do this. So Z, let's look at this bit here. We've got 130 plus 40. So that makes 170 degrees. If I add 130 plus 40, and therefore this whole thing here has to be 180 degrees because it's a straight line. So you do 180 minus 170, which is 10 degrees. And my answer would be angles on a straight line. A straight line equal 180. Okay. Now the other way you could do that is you could look at this backward C here, like I just said a second ago. I know that that makes 130. So therefore this altogether here would have to make 50, because co-interior angles have to add to 180. And if I've already got 40, then that would make 10. Okay. So that's your question 12, angles in parallel lines. Always look for a triangle. Always look for your Z shape, your F shape, your C shape. Because again, here I could also look at the fact that, if I rub that bit out there, and let's change colour. Here is a Z shape, which means that this angle and this angle has to be the same. If that's 50, that would make 50 as well. So there's multiple different ways you can look at it. And you will always see that Z, F and C. You've just got to use the right one when you need to. Okay, next one, highest common factor, lowest common multiple. So I'm going to do this using a Venn diagram and prime factor tree. So the first thing I'm going to do is 120. And I'm going to split that down into 12 and 10. 12 breaks down into 6 and 2. Circle that because it's a prime. 6 breaks down to 3 and 2. They're both primes. 10 breaks down to 5 and 2. They're both primes. And now do the same for 150. So 150, 15 and 10, 5 and 2, 5 and 3. They are all primes. The next thing I would do is I'd write them out in a list. So 2 times 2 times 2. So 2, 2 and 2 times 3 times 5. So that's my 120. I'll do the same for 150. 2 times 3 times 5 times 5. Now, you might have seen this before, you might not. The way I like to answer these questions is by drawing a Venn diagram. and then I'm going to put 120 here, I'm going to put 150 here, play a game of snap. So what's in both lists? Well, I've got a 2 there and a 2 there, so a 2 goes in the middle. I've got a 3 there and a 3 there, so 3 goes in the middle. I've got a 5 there and a 5 there, so the 5 goes in the middle. Nothing else matches up. What's left over? Well, there's a 5 left over for 150, and there's 2 2s left over for 120. So that's my Venn diagram. I fill that information in. And then from here, to find the highest common factor is just the middle section. So it's these numbers here, you multiply together. So it's 2 times 3 times 5, or 2 times 3 is 6, 6 times 5 is 30. So your highest common factor of 120 and 150 is 30. You might have been able to spot that already anyway, but if the numbers were much bigger and much more awkward, that's how you do it. And then to find the lowest common multiple, what you're doing is you're multiplying all the numbers in here. Okay, so lowest common multiple is 2 times 2, because they're my 2 2s, times 2 times 3 times 5, that's the middle section, and then times that 5 on the outside there. When you actually do that, 2 times 2 is 4, 4 times 2 is 8, 24, 24 times by 5 is 120, and then 120 times by 5 is 600 and 600. Okay, so your lowest common multiple ends up being 600. Okay, so that's one way of doing highest common factor, lowest common multiple. It doesn't have to be that way. You could do your 120 times tables, 240, 360. You could do your 150 times tables, 300, 450, and then obviously then you get to 600, and 600 will be the first one that shows up in both lists. But sometimes if you have really big numbers where it take you ages to do that, it's quicker to do it this way around. Okay, right, moving on. So we're going to look at equations of lines and then a bit of substitution next. Last 6 questions for us to go through. Okay, so I've just added in the squared background for you here, so it's easy for us to plot the graph. So it says plot the graph of y equals 7 minus x. The first thing to think about is whenever you get a question like this is it has to be in the form of y equals mx plus c. This bit here is your gradient, and this bit here is your y-intercept, okay? So it's really important to get your head around those values. Now, this is slightly different the way it's written, because actually your y-intercept is first and your gradient is second, but you know, I could still write that as y equals minus x plus 7, and that is the same as that bit there. Okay, now it says do not use a table of values. And what I mean by table of values is you would sometimes get given in an exam this. It would say minus 3, minus 2, minus 1, 0, and you would have to fill that in and then plot it from there. If it tells you not to use a table of values, here's how we do it. So let's get rid of all of that. We know that the y-intercept in this question is 7. So on my y-axis, I go to 7, okay? And I put a cross. So that's your y-intercept. It's where it crosses the y-axis. That's your y, that's your x. So the first thing I do is put a cross at 7. My gradient is minus x, which means it's minus 1. So this bit here is your gradient. So what I do is I go across 1. And because it's minus 1, I then go down 1. Okay, if it was plus 1, I'd go across 1 and up 1. If the gradient was plus 2, I'd go across 1 and then up 2. So it's always across 1 and then up or down the gradient. Okay, so make sure you are aware of that. So let's look at this then. So 7 is where I'm starting from because that's my y-intercept. I go across 1. Now that's not 1 in this case. Always read the scale. 1 in this instance is 2 squares. So I go across 1 and then I go down 1. And actually on the y-axis, 1 square is 1. So you can see there, this goes 1, 2, 3, 4, 5, 6. So a lot of the time in exams, you'll see your x scale and your y scale are different. So I'm going across 1, down 1, put across. Do the same again, across 1, down 1, put across 1, down 1, put across. Now I've run out of space on the graph this way, so all I do now is go across 1 the other way, and then up 1, across 1, up 1, and then across 1, up 1. And that is my line that I will be plotting. You use your ruler, join the points together, and if you have a random point somewhere, so let's say for example I had a point here and I was drawing my line, that point doesn't fit in, you know you've made a mistake. Okay, so your points should all join up and all line up quite nicely. Let me just show you a slightly different example. If it was this, y equals 2x plus 4. So if that was the graph, 4 is my y-intercept, so I go to 4 there. That's my gradient of 2, so I'd go across 1, and then up 2, put across there, across 1, up 2, across 1, up 2, run out of space, go the other way, across 1, down 2, cross 1, down 2, cross 1, down 2. So that green line would be y equals 2x plus 4. Okay, again, link in the description. I've done a video on that if you need to spend a little bit more time on it to get your head around it, but that's how you do it about table of values. Okay, question 15. So we're looking again straight away at getting our head around BIDMAS, but this is substitution in BIDMAS. So it tells me x is 4, y is minus 3. So remember, 6x means 6 times x. So I'm saying 6 times 4 minus 3, and it's times y squared. So in your exam, just for writing that out in the correct format, gets you a mark, right? I'm saying that x is now 4, and I'm saying that y is now minus 3. So even if you mess up the next part, you've secured yourself 1 mark. From here, we're going BIDMAS again. Okay, so are there any brackets? No. Are there any indices? Yes. So do this bit first. Now, minus 3 squared means minus 3 times minus 3, which is a positive 9. So that turns to positive 9. Then I start filling in the rest of this. Okay. So now I go, is there any division? No. Multiplication? Yep. So there's multiplication here, and there's multiplication here. So it doesn't matter how I do them. I just need to make sure I do them correctly. So 6 times 4 is 24. Now what you've got is minus 3 times 9, which is minus 27. When you've got a positive times a negative, the answer is a negative. So 24 minus 27 is minus 3. Okay, so that's your answer for the substitution part. Okay, question 16. So we've got a transformation here now. As soon as you see the word transformation, what I suggest you do is you write down E-R-R-T. Transformations really So enlargement, and using is the way I just remember them. Rotation, reflection, and translation. What you know is you have to say one of those words for this, because it's a single transformation. If you put more than one, you're going to get it wrong. So, which single transformation takes A to B? Well, has it got bigger? No. So it's not an enlargement. Has it rotated? So has the shape spun round anywhere? No. Has the shape reflected? Well, if it had reflected, it would be on the same line, so it wouldn't move up or down. And then translation is the shape being exactly the same, it's just moved. So yes, you can see here, A to B is very clearly translation. So sometimes the mark scheme will give you a mark just for writing the correct word, or you need the word with another part. So translation gets you a mark potentially, but then with translation, we need to say what the vector is. Okay, so translation by the vector, how do I go from A to B? Well, pick a point. I'm going to go from that point to that point, make sure it's the same point. I go 1, 2, 3, 4, 5, 6, 7, 8, 9 right. So I'm going to just write that down here, 9 right. And 1, 2 down. So I'm going 9 right and 2 down. I write that as a vector. It becomes positive 9 and minus 2. Okay. The value at the top tells you if you're moving left or right. So because I'm moving to the right, it's a plus 9. And then the value at the bottom tells you if you're moving up or down. Because I'm moving down, it's minus 2. Transformations, again, check the link in the description. I've done a video on transformations. If it's something you need to revise, it comes up every year. Will probably come up in every paper, so make sure you are comfortable with that. Okay, but the vector is what you need for translation there. Okay, Moving on now, I'm going to get rid of the squared paper for you, and we're going to move on to the last little bit. Okay, here we go. So we're looking at question 17. We're going to form and we're going to solve an equation again. So the first thing I'm looking at is, this question is about area. So I'm not even going to read the whole thing. I'm just going to look at what it's about. What area of maths is this about? Well, area of a triangle is base times height divided by 2. Area of a rectangle is just base times height, or you could do length times width, whatever. So let's do the rectangle first, a bit easier. So I'm saying that times that, because it tells me the area of the rectangle is equal to the area of the triangle. Well, so if I do this bit first, I'm saying 5 times by 2x plus 3. So that's one side times the other side for the rectangle. I expand this out. 5 times 2x is 10x. 5 times 3 is 15. So I'm saying that is the area of the rectangle. Now I need to do the area of the triangle. Well, base times height. Well, the base is 4x minus 10 and the height is 7. So I can say the same thing here. That's 7 multiplied by 4x minus 10. And then I need to divide it by 2. So 7 times 4x is 28x. 7 times minus 10 is minus 70. Divided by 2 becomes 14x minus 35. So that's the area of the triangle. Now it tells me that the area of the rectangle is equal to the area of the triangle. So I can then say 10x plus 15, area of the rectangle, is equal to 14x minus 35. So I've just formed an equation here that now I can actually begin to solve. If you have x's on both sides of an equation, move the smaller x. So the 10 is the smaller x, it goes that way, which means this number needs to go the other way. And if you need to do any more work on solving equations, make sure you watch my video I've done on that. So that becomes 14x, and it's now minus 10x, because when I move it over the equal sign, it changes sign. And the minus 35 becomes plus 35, so you're saying 15 plus 35. So we're saying 50 is equal to 4xm. So then get the x on its own, take the 4 over, divide by 4. You could say you just half it and half it again to divide by 4. So that becomes 12.5 is equal to x. Okay. So we just picked up another mark. We picked up a mark here for forming the equation. Sorry, here for forming the equation. We picked up a mark for finding the value of x. Now what I need to do is go back up to this and substitute it in, because it says find the perimeter of the rectangle. It's not asking me to find the perimeter of the triangle, just the rectangle. Well, 2x means 2 times x, and we're saying x is 12.5. And then add 3. Well, 2 times 12.5 is 25. 25 plus 3 is 28. So this side is 28, which means this side is 28, and this side is 5 because they are opposite each other. Remember, perimeter is just all the way around the outside. So I'm saying 5 plus 28 plus 5 plus 28. So 28 plus 28 plus 5 plus 5 is 66. So that is the perimeter of this rectangle. Okay. It could be in centimeters, could be meters. We don't know. It doesn't actually tell us the units in this question. Okay, so that's how you'd answer question 17. Question 18, Venn diagram question. Okay, so a couple of things we need to be aware of. We need to know what this means. Okay, so this is basically telling me all these numbers need to go in this Venn diagram somewhere. It tells me that A are prime numbers. So anything in here is a prime number, and B, anything in here is an odd number. So I'm only going up to 15. It doesn't include 0 because you can see that there's no 0. So what I'm actually going to do is just here, I'm going to write all my prime numbers in that list. So 1's not a prime, it doesn't count, but 2 is. So I'm going to write 2. I know 3 is a prime number. Remember, a prime is a number that can only be divided by itself and 1. 3, 5 is a prime. 7's a prime. 9 isn't because 3 goes into it. 11 is a prime. And 13 is a prime. There's no other primes in that list. Then what I'm going to do here is I'm actually going to write down all my odd numbers as well. So 1, 3, 5, 7, 9, 11, 13, and 15. So from here, what I need to do is I need to fill in my middle section. My middle section here is in this bit here. and numbers that are in both lists? Well, I can see 3 is in both. So I'm going to put 3 in there. And then what I'm going to do is I'm going to cross it off on this list. You can also see 5's in both. So I'm going to put 5 in there, cross it off. 7's in both. So put 7 there, cross it off up here. I can see 11's in both. So put 11 there, cross it off up here. And I can see 13 is in both. Put 13, cross it off up here. So I've done my middle section and I know that's right because I've crossed stuff off as well. But the reason I'm crossing it off is because I need to know what's going to be left over that will then have to go on the outside. So now let's see what's left. Well, in A, I've got a 2 left over. So there's going to be a 2 just there. And in B, I've got 1, 9, and 15. 1, 9, and 15. So I can then cross all those numbers off my list as well. So I've done 1, I've done 2, I've done 9, and I've done 15. So now what I'm left with are the numbers here that are circled, and all of those need to go in my Venn diagram. Well, they're not prime numbers and they're not odd numbers, so they then have to go on the outside. 4, 6, 8, 10, 12, 14. So what I suggest you do is with Venn diagrams, take your time, write the things out carefully, and cross it off on the list once you've put it in your circle, because in your Venn diagram, sorry, because then you know you're not going to duplicate numbers, and you know numbers aren't going to end up being in the wrong places. Okay, so that'd get you 3 marks. So a Venn diagram tends to get you 3 marks. It's a mark for getting a couple of the sections right, and then for the fully correct diagram is 3. So it then says a number is selected at random. Find the probability of A and B. So this is a bit of set notation. This means A intersection B. If you need a little bit more revision on Venn diagrams, I've done a video on that, so check the video description and click on the link for that. So A and B, that just make the way I'd like to think of this is like fish and chips. Okay, if you have fish and chips, you're having both, which means it's that middle section there. Okay, so if you're having fish and chips, so you can think about it like that, middle section. Well, how many numbers are there? 1, 2, 3, 4, 5. So there's 5 numbers out of how many numbers are there all together. And again, if you're not sure, just count them. There was 5 there, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 5 out of 15. And if you wanted to, you could simplify that. So both divide by 5, so it becomes a third. Okay, so probability doesn't have to be simplified, but it's not a bad habit to get in just to simplify it where you can. Okay, so that's your Venn diagram. Last couple of questions here then. We're looking at a bit of estimation, and then we're going to look at some bound stuff to finish off with, okay? Okay, right, so question 19. A delivery van has a load space in the shape of a cuboid. So that's what I've got here. This is my delivery van. That's the back of the van that would be filled up. It says each package it delivers is a cube with sides 45 centimeters. So basically what I'm saying is I've got these packages that are all 45 centimeters that are going to go into this van. Assuming all packages are the same size, estimate, keyword here, estimate how many packages can fit inside the van. So my van would look, as I say, a bit like this, and we're saying it's in the shape of a cuboid. The key word to this is it says estimate. So what I need to do is I need to round all these values. So 1.8 is going to become, and I'm going to use this symbol here, which is approximately. That's going to become 2 meters. The 2.7 is going to become 3 meters, and the 2.1 is going to become 2 meters. So just for doing that, you'd pick up a mark anyway. Now the 45 centimeters, I would say as well, is going to become 50 centimeters. Okay. Generally speaking, when you are estimating, you round to one significant figure. So the one significant figure here is 1. What does the 8 do to the 1? It pushes it up to 2. The one significant figure here, the 7, pushes the 2 up to a 3. And then the 2 here is the first significant figure, so the 1 keeps it as a 2. And then here, your first significant figure is 4, so the 5 pushes it up. So, key thing is that we have got centimetres, but we've got metres. So we are going to have to do some conversion later on. Now, all of these packages, So these boxes here, what I'm doing is I'm picking them up and I'm going to be dropping them into this van and seeing how many of those packages I can fit into the van. So what I need to do is think that this question is all about volume, okay? If the question was about painting the outside or something like that, it'd be surface area, but this one's all about volume. So the volume of the van is what I'm going to work out first of all. So the volume of the van is going to be 2 times 3 times 2. Okay, so height times width times depth, or height times depth times width. Or if you want to think about it, you're doing the area of the front face, so you could call it 2 times 2, and then you're timesing it by the depth. However, this is all in meters. So instead of it being in meters, I'm going to change it to centimeters. So that's 200 centimeters, that's 300 centimeters, and that's 200 centimeters. Okay, the reason is because it will be a little bit easier to work out later on. So I'm actually saying 200 times 200 times 300. Well, to do that, I just do 2 times 2, which is 4 times 3, which is 12. And then 1, 2, 3, 4, 5, 6. My zeros all go back on. Okay, so I'm saying this is 12 million centimeters cubed. That is the volume of the van. The volume of each package is 50 times 50 times 50, because it tells you each one's a cube, so they're all the same size. Well, 5 times 5 is 25, 25 times 5 is 125, and then you've got your 3 zeros on afterwards. So each package is 125,000 centimeters cubed. The whole thing is 12 million centimeters cubed. I need to estimate, and I've already rounded the numbers, so how many times would this go into that? So I'm going to do 12 million divided by 125,000. Those 3 zeros can cancel out those 3 zeros. So I'm effectively doing 12,000 divided by 125. Okay. Now, that's quite difficult to do, but you do know if I times that by 100, if I did 125 times 100, it would end up giving me 12,500. So it's going to be close to that. One thing I would say is that with 125, you know you're going to go 125, 250. Now that's twice. So 125 goes into 250 twice. And then to get that to 1,000, let's just do that. So that would be 375, and then 500, 625, 750, 875, and then 1,000. So for me to go from 125 to 1,000, what I've done is I've gone 1, 2, 3, 4, 5, 6, 7, 8. So 125 goes into 1,000 8 times, and I need to get it to 12,000. So I times that by 12, which is 96 times. Okay, so 12,000 divided by 125 is 96. So therefore, you could say your estimation, your approximate how many packages could be fit in would be near 96. So it'd be somewhere, there'll be a range that would be allowed, but 96 is what you get from doing the working out that I've done. Key thing to remember is that because it says estimate, it's asking you not exactly. So if you sat there and worked it out perfectly, you wouldn't get the marks. It's about rounding the numbers and working it out from there. Okay, right, last bit then, question 20. So it says a number has been rounded to one decimal place. The resulting answer is 5.7. Write the error interval for x. So again, if you're not 100% sure on error intervals, I've done a video on this. It could be worth you watching that. It's not a very long one, but just to get your head around what to do. So the way I like to teach this is to think you live at number 5.7. It says it's been rounded to one decimal place. So you go to your next house. Well, the next house would be 5.8. So that's my next door neighbour. And my previous next door neighbour is 5.6. We're ignoring the fact the houses go up in twos. Just assume they go up in ones for this. I don't get on with my next door neighbours, so what I'm going to do is put a fence up in between them. So instead of it being 5.6 and 5.7, in the middle is 5.65, and here in the middle is 5.75. So this is what we call our lower bound, and this is our upper bound. And therefore, those are the two numbers that you end up putting here. So 5.65 goes there, that's your lower value for your error interval, and 5.75 is your upper value. To be careful on the wording on that. Some of them are worded slightly differently, which involve a different answer, but watch the video I've done on error intervals and bounds if you want some more information about that. Okay, so 20 questions we've gone through in this foundation style, 51 marks. Obviously, the exam that you'll be sitting will be out of 80, so we haven't necessarily gone through everything, but we've gone through some of the key things. What I suggest you do, if there's anything that I've gone through on there that you got wrong, you weren't sure on, go into the description go into the links in the description and rewatch the video on it that I've done, or make a note of it and do some more revision on those topics. Okay, hope you found it useful, hope it helps you, and good luck in your exams in the summer.